Good evening, everyone. My name is Sybil from Iran. I'm very excited to present to you one of our first webinars of the year, and hopefully around quite a lot of relevant topics that we all are interested in throughout the whole of the year. I just have a few things to say, or just a bit of house rules. Please just make sure that you're on mute. And if you would like to ask a question right at the end, just make a note of it, and there will be some Q&A with Pieter afterwards. I would love to introduce you to Pieter. He is a senior data scientist at Wonga, and he actually builds AI bots for a living. So he'll be giving us quite an informative chat about what he does and everything around AI bots. So without further ado, I'm crossing over to Pieter, and I'll chat with you all a little later again. Thanks, Pieter.
Okay, cool. Thank you, guys. So this talk is not going to be a sort of like in-depth jumping into code, doing all the frontline work. It's more of like an overview of what agents do, what a AI agent is, what a workflow is, and how to do a little bit of context management. Just because this is, if you understand the concept of it, you can go learn the code and do everything like that and know exactly how these things work. So I don't know if all of you are interns or looking at the subject or already built something. Hopefully everyone going to find something out of here. If you have some questions, I'll answer it afterwards. And I've also linked a few resources at the end, just if you want to know where to go next. So yeah, let's jump into it. Oh, okay, the presentation. So just to take you through what we're going to talk about. So just going to go through who am I, short history of AI, just to see where we came from, where we're going, going to talk about agentic workflows, AI agents, and then just some context management. So who am I? My name is Pieter Gouws. I'm AI adoption lead at a fintech company called Wonga, where we do short-term loans. So I find ways of how we can implement AI solutions in a way that people are going to use it, it's going to make money, and it's really going to help the business. It's not just saying we're using AI. I studied mechanical engineering, and the funny thing about that was I didn't want to go study electrical engineering because I was afraid it was going to change too often. And now I work in AI where everything changes every month. So that was quite an interesting twist my life had in for me. And yeah, the second part I already mentioned. Okay, so a short history of AI. It all began in the 1950s with the Dartmouth conference. It was basically a conference hosted by John McCain, who was the head, I think the head scientist there at the moment. And he basically said in his proposal that the conference was to proceed on the basics of the conjecture that every aspect of learning or any other feature of intelligence can in principle be so precisely described that machines can be made to simulate it. We all know Alan Turing, that also in 1950 published a paper called Computing Machinery and Intelligence. And he basically said if a machine could behave indistinguishably from a human in conversation, Turing argued that it should be considered intelligent. Now, if you look at some of these LLM models, some of them are indistinguishable from human conversations. So I think we almost passed that part. It all then went into expert machines in the 1980s, which was basically a field where people took one job and encoded it into computers. And that computer was then an expert machine to analyze gas emissions and a bunch of stuff like that. So that was sort of like the next step. Then we got to statistics and machine learning era in the 90s. This was basically where all the random forest and tree tree selection models was created that most of us still use in classic machine learning. And it was also when IBM's Deep Blue won against Gary Cook, which was the first sort of like one computer systems against humans. That then carried on to the 2010s, and then a big breakthrough happened in 2012 with the AlexNet, which was basically our first step into convolutional neural networks that's then used to identify photos and all the stuff that we have today. Then came the BERT model. The BERT model was the bidirectional photo representation of transformers, and read up a little bit about it. It seemed like that they created in the beginning with sentence from the one side over trying to get the context, and those were called directional encoder models. But what BERT did differently was it bidirectional, so it went from both sides and then gained more context what was said in a sentence. So it was the first sort of like natural language processing model that we had. Tested it out, and it was the most amazing thing. If I told it say something like this and it say it like that, and I was like, oh gosh, this is so cool. Then I think when most of us got into this with the release of ChatGPT and Gemini and all the models, ChatGPT was a very good one. Gemini was a little bit slow out of the blocks, but it came around, and that's basically where we are now. We got these models, they are chatting to us, they're helping us solve problems, but people still runs into the problem from how can I make this a human? How can this be like a remote worker where I can just tell it to do stuff, and then probably in 5 to 10 years time from now go into humanoid robots, and no one's going to cut grass anymore. So jumping into it, agentic workflows. So when I started working with agentic systems and seeing how we can get LLMs to do stuff for us, I was like, AI agents, let's go. And then soon realized if you're working in a financial industry specifically, you can't do that. You're giving too much freedom to the model. So agentic workflow is a system whereby a large language model are orchestrated through predefined paths to complete well-defined tasks. So it's basically a workflow of stuff that already happens that's programmatically, plus some LLMs in to make some functions more easy. It's well-defined, so it's for tasks where you know this has to happen, then this, then this, then this, and then I want this answer at the end of the day. And it requires predictability so that you exactly knows this is what it's going to give to you. You test it on a bunch of examples and you know it can handle everything we can throw at it. And it's very important for the decision and outcome. We want to exactly see what decisions it made and how it came to the outcome. And to be honest, most solutions can just use a agentic framework of a workflow. There's a very small amount of tasks that we can do where we actually need agentic AI that can think for itself. But that's for the current problems that we have. I'm sure in the future we're going to get more AI agent type of problems. So examples of agentic workflows is, let's say you're working on the document extraction. You have your document, and then you put your LLM there to say, what's in this document? How can I extract data from it? You then extract data, and you then have a human in the review just to check if all the stuff is correct. And then it updates some process, like send an email, update CRM system, communicate back to the customer, anything like that. That is basically what this workflow is. The human in review, I've seen you use it for the first few months, and then after a while, when you get more confident, you'll periodically review the systems. Another example is WhatsApp. This is actually a very interesting problems you can run into, because a lot of customers or businesses want a WhatsApp system where they can chat to it, or not necessarily have a chat bot, but a sort of like routing system where a customer can ask for their statements, or a customer can ask normal queries that they would call a call center for. So with that, you can have a message that comes in from a customer. LLM would then analyze it, and then you can have routing. So It can either go one direction that was decided by the LLM that can then, let's say, schedule a meeting. You can have a human interview just to double check the stuff, and then it would then send out emails to create meetings. Or you can have a system where it retrieves information from a database, human reviews it, and then another message can then be sent back to the same customer. Another example, I think this is my last example, is a SQL query. So this is very important, especially if you are a data scientist and you are not in the mood for ad hoc query. This can help you a lot. So basically, a user would come in and say, what was the sales for last financial year? Oh, that goes back. For the last financial year. And then you would get a text-to-query engine. It would then query some RAG system that knows your database, knows where to get information, knows what are trusted queries for certain systems. And it would then spit out a query that is exactly what you want it to be. Other steps can then take it further to actually execute it, get the data back, represent it for you in an Excel or whatever you would like to see it in. So what are some examples of this? There's a few companies that do stuff like this. First examples is your no-code examples. So that's Make and Zapier. I've had some experience with Make. It is super nice if you're not a technical person. It's quite a bit frustrating if you're a technical person because it's a very nice plug and play, but it can't go into detail into the stuff. Then low code, where you do have to have where you can use some code, is N8N. It is I might be biased, but it's a gem to me. It just helps you so much. It does have its limitations, and as soon as you start using it and solving problems, you do run up to it. But it's such a nice way to learn how to do these type of workflows. And then a code-first solution would be something like LangChain. LangChain, you can obviously do agentic AI systems where stuff thinks for itself, but you can also do agentic workflows. Then AI agents. So these are more models where you give a little bit more agency to. So instead of having a workflow and only giving it specific information and expecting specific stuff back, you basically give the LLM instructions and tools, and you give it an open-ended task. It's open-ended task is something where you can't plan the steps it would need to take to come to an outcome. You just like, I need this one thing, please help me with that. Another advantage of agentic systems is it can troubleshoot. So if you have a workflow set up and it needs to query a database and your VPN is off or you don't have access to that specific table, the LLM can, the agentic AI agent can then go and say, okay, how can I troubleshoot this? Maybe I should change the query, or maybe I should call in a human for a human intervention, where workflows will just fail. And basically, AI agents is when you need more flexibility versus predictability. So as I say, you basically have the sliding case where on the one side you have control, on the other side you have autonomy, and with agentic workflows you have a lot of control, but with AI agents you have a lot of autonomy, and it depends on the type of industry you're working in, the type of problems you're facing, what type of systems you would be allowed to use, and what you want as a solution and how specific you want that to be. So how basically an AI agent works is you always start with an LLM in the middle from some LLM provider, and then you would give it a system prompt. And what a system prompt is, it is a detailed description of what you want the agent to do. Now, I would always recommend someone to start with a simple system prompt on this side. So I gave it a scenario that it's a zoo, AI agent working at a zoo, and it needs to help customers. And the best way for me to write a simple, or to write a system prompt is not to go take a course for 3 months learning how to do it, but it's actually just to use any LLM to help you write the system prompt, and just tell it what you want it to do. So I gave this to ChatGPT, and then it gave me a simple, you are a zoo information assistant, you answer this question using the provided zoo rules, animal facts, and opening hours. And it basically follows the same format. It gives it the persona, it gives it sort of like what its goal is, and then what it shouldn't do. And then as you work through your examples and you get, in this case, more questions from visitors, you can then decide to close it down a little bit by giving it you mays and you musts to make sure that it doesn't go off and gives ludicrous answers. But my best advice for you is just start as simple as possible, get something running, and then chip away on it as you go. Then you would also get, you can give your LLM some knowledge. A RAG system is a super nice version of that, because you can take a lot of information, put it in a database that is vectorized, and then it only retrieves the data that's needed. So just if you don't know what RAG systems are, it is a database with a knowledge store, storing data like documents, knowledge-based articles, transcripts, web content. It could be if your model works with customers, previous cases where you worked with customers that you work with in the same geographical area, all type of data like that you can put into a RAG model. That data is then chunked. You will hear, if you work with RAG, you'll hear everyone talking about chunking. So it basically splits a document into sections of text, and then it would vectorize it and put it into a database so that a computer system can get easier access to it and find all the relevant information. So now we have our system prompt to give it instructions on what to do. We've got a RAG to give it more knowledge about what it needs to do. Now it actually needs to do something. And this is where tools comes in. And as you can see, the interaction between an agent and tools are circularly. You know, it goes to the tools, get information back, decides if it needs to go to the tool again. And what the tools could be, it could be coding or execution tools. An example of that is I've worked on a place where I had to, worked on a case where I had to count a lot of numbers together. And LLMs are very great at identifying numbers, but very bad at summing numbers. So I then had to add a calculator to it to calculate this, the sort of like the total aggregate in a month or something like that. And that works very nicely. So that's the idea of a tool, MCP service. Most apps has MCP service at this time. You also get stuff like Moltbot or Claudebot that can create MCP service and skills exactly what it needs to do to interact with stuff. And then you also get actions in system tools. This is to like create, update records, and send notifications. And then obviously your LLM is going to start. It's going to know its instructions, know its data, work with its tools to resolve this problem. And then at one moment, it's going to have to get to a point where it's like, I have to end now. I'm done with this question. And that's also a very powerful thing where with Magic, this LLM can just decide, I'm done now, and then give you the solution. So an example of this is, let's say you have a software developer agent, and you give it a task, like develop a snake game. It would then go and it would define the tasks that need to be done. It would then select a task, complete the task, and then reflect on what it completed. And then it would choose the next task, select the task, and go through this whole flow. If you recognize this architecture, it's basically what everyone is talking about, the Ralph Wiggum architecture that was, I think it was brought out in the middle of January or early January. But it's a great thing, especially with Claude Code, something we're definitely looking into. To give you a practical example of sort of like a data science-y solution for this, with the agentic workflows, I mentioned that you can get a text to query engine that can basically just develop, give you all the queries that you need to have. Now, the people at Snowflake developed something that is much easier to set up. It is an agent, and and it's called Snowflake Intelligence. And it was the first time where I actually felt scared for my job because it was just so good that I saw, whoa, this is the stuff that I did when I started data science. So basically what they have is they work with normal large language models. They have your context, which would be all your data in your database in Snowflake, but you can also add data from documents. You can add data from, let's say, a Hello Peter page or some social networks that it also can reference, and then it would give you insights or answer your questions. So one example of this was if a salesperson would ask, show me the trends of sales by product category between June and August, and it would then give you all the answers you would need. It would give you graphs. It would give you a full report on what happened, why you did. Some of the other examples they went into was to ask, why was sales down in December? And it would do a full analysis for you exactly why sales were down, look at previous years. So, and this is what I did as a data scientist when I started. So I was like, yo, this is very, very, very cool and very scary at the same time. But obviously it comes with the token usage and all of that stuff. But, you know, it's still a very nice solution, especially for other queries. So if we're looking at agents versus workflows, for the best results, simple prompts. So if you're working with your LLMs in workflows or your agents, start as simple as you want. Just give it a persona. I would start with asking a LLM to help you write the system prompt, but start as simple as possible, or as simple as you possibly can, and then iterate on it. And then adding tools, I would suggest adding tools sparingly. It fills your context window and it costs a lot of tokens if you use tools unnecessarily. So only if you really need it. So I went and created the agent, did a few tests, see in what cases it does need a calculator and what cases it doesn't, and then only added it for that specific sections where it really needed it. And then optimize your system with comprehensive evaluation. So test everything. If you have to handle a bunch of cases, test all the cases, test all the edge cases, throw curveballs at it and see what it needs. And then you can also get multi-step agents. I think I'm going to go into it in a few slides, but use multi-agentic systems only when simpler solutions fall short. So always begin with one, see how far you can go. And if you do need a multi-agent system, only go when your single system couldn't handle that. So then we get to context management. So one of the most important things about both of these workflows and agents is the context you give an agent. So it's the basic art and science of figuring out what needs to be in an agent's context for each step of its trajectory. And it is super important. So if we look at your at a normal agent, at the end of the day, it's a pure function. So you have a, ooh, Lorenzo, you got me on there. So you have an LLM, which is a pure function. So basically what that means is your input tokens is just as good as your output tokens. So all that you can basically do with this, other than selecting a different model, setting the temperature of your LLM and training a model, is basically, if you want to increase the quality of your outputs, you should increase the quality of your inputs. That's all of it is. And what context what context management does is it basically makes a small model a smart model, and it's just is how we can get the most of the models that we have today. But on this point, I also have to tell you the predecessor to context management or engineering was prompt engineering. And I remember at the time, everyone was like, oh, prompt engineering, everyone should study it. And then like a year after that, LLM started figuring out how to do their own prompts and how to do prompts better than people can. And now this poor guy started studying prompt engineering and didn't even finish his degree before it became irrelevant. So I believe context management, context engineering is going to take the same route. I think it's going to come up to a point where LLMs are just going to be able to handle this. But as the line says, it's how we can get the most out of the models we have today. So if we look at the context and what can go into the context of a model, let's start with how big this context is. So if we look at OpenAI's GPT 5.2, that's about 400,000 tokens. If we look at Claude has about 200,000 tokens, and Gemini Pro has about a million tokens. And what is put into your context is basically all your documents. If you add documents, all your tools, those are quite large. You got your memory files that you give memory to your agent to, domain-specific knowledge, your system prompt that we spoke about. But the biggest guy is your message history. So I don't know if you guys notice, but when you have a conversation with the LLM and you ask it questions and it goes back and forth, every time you make an LLM call, it takes that whole message, that whole list of messages, and posts it with every time you prompt it to get the full context. So you would get to a point where your model starts getting slower and start not really working as well as you want it to, and that's what we call context rot. So it's the gradual degradation of an LLM's ability to correctly use early information in a long context. And you can see with most models, as soon as the context length gets longer, the effectiveness of the model dramatically tapers off. And then you get to situations where I've had a few of my employees that would go and have this very long thread, and then at the end of the day feel too bad to leave the thread because they just got this prompt in the right way, but it's getting so bad they are forced to start a new thread. So what can we do? And looking at all the stuff that goes in here, what's the first thing I would ask you to do? So here I have a small little diagram of your history, messages, and everything going in. So if we can take this in a way, we can shorten it or compact it so that our agent doesn't have this massive context of you asking a few questions, saying thank you, and a bunch of stuff in there. That could help us a lot by minimizing the size of our context. So the first thing, and a lot of, if you're doing some Claude courses, they would actually advise you to do this, is where we can summarize, compress all the knowledge that we have now. And they do that by asking the LLM to write or to edit what they call a progress markdown file. And the progress markdown file just basically gives a summary so that any other agent can pick this up and carry on with the task. The other solution that we have is using a sub-agent architecture. So let's say you have a user prompt that comes in, your main agent, which might be a big one, let's say Claude Opus 4.5, gets the prompt and it needs to go do some research. It would then shoot this query off to a sub-agent, which might be a much smaller agent, that would then go and reach out to a tool or the internet and then get information back, and then send a summarized version to your main agent that would then continue your flow to the next step you want to go into. And in that way, it doesn't have to have this massive context of all the research it has to do. It just needs, it gets the information that it needs. Another example is selective context. This is my favorite one. So let's say you have a document, you have a LLM analyst again, and you extract some data, and then instead of saving that in your message history, you go and you save it on like a scratchpad or a JSON file. And when you're working with LAN graphs in the LangChain framework, you get a state, which is basically like a big class that you can save all this information in. And then just before you need to make a decision with this, you'll put that information back in, it will make the decision, it will go forward, and then after that you take it out of the context again. And that just helps you reduce your input tokens, which would then save you a lot of cost on your API calls. Then another thing that you can do is we spoke about RAG, where you basically take documents, vectorize, chunk and vectorize it, and then your LLM can just get the information that it needs, that is relevant to it. But what I found can just take RAG to the next level is if you would go and you would use a hierarchical context. It basically gives it a summary of all the information, add some metadata like a company name, previous cases it worked on this, geographical information. It could be if it was from a specific book or a specific source, you can add that, and then you give it the raw data so that your LLM can use the metadata to filter on the options that it needs. Maybe just use a summary if it doesn't have to go into depth, but always have that raw data at hand if it does need it. And then basically coming to sort of like a close on this talk, I thought I would just give you sort of like an idea. If you would go into agents, like I can speak for hours and take you through so many examples of exactly what you need to do. But at the end of the day, you'll have to figure this out for yourself. And there's a bunch of very good resources out there, much better than I would ever be. And these are just some examples that if you're starting from nothing, what I would have done. So the first one is to create a no-code chatbot. The easiest one for me is a custom GPT. So if you go on OpenAI's website, create a custom GPT, you'll see you have to describe a sort of like system prompt. I think it says in the description. You can add tools to it, give it code evaluations, give it internet access. If you're very brave, you can add some actions to it as well. And then you can create this thing and iterate on it. You nicely get two screens. The one side you can edit, the other side you can test, and then you can get exactly what you want out of it. Then you can go into some no-code architecture or orchestrations. This would be Zapier, Make. Just play around with it. This gives you a little bit more real-life stuff where you can build an agent that replies to emails or makes appointments or go through that stuff. Then if you really want to get into it, you go to a low-code orchestrator, which is a N8N. Like I said, I like it a lot. This is also the one that can integrate with WhatsApp, you can integrate with Telegram, and do a bunch of useful stuff for you. And then once you're done with that, you can go into some agentic workflows and frameworks like LangChain, Crew AI. You can even do some pure Python ones if you just want to get a Python one, understand what's going on there, and then start working on graphs in LangChain, and just hone your skills over there. And then lastly, just some courses and resources that I would go into. So I spoke about software intelligence, Snowflake's intelligence. So I left some links here. I don't know if we can share this. I'll give like a very shorter version of this presentation if they want access to these links.
I wonder if we don't share just the links in the chat as well, if possible.
Okay, I'll share the links in the chat.
Yeah.
You can also screenshot this and then test your typing skills by typing it into the browser. So it is Snowflake Intelligence. It's a very nice course. Snowflake also gives you a trial version that you can use for a month if you want to get into that, but building agents over there. Then LangChain Academy, very nice. When I started learning, I was like, okay, I need to learn this stuff quickly. Let's do LangChain, and after a week, I could actually do something. Another one was a course that I got into that is a little bit more high level, which is AI agents and agentic AI with Python and generative. I'm guessing the I escaped there, which is a paid course by the University of Vanderbilt, which is what I got a lot of stuff out of there. And then agentic AI is given by a guy called Andrew Yang. If you've done anything in data science, you know Andrew Yang is the guy, and he gives a pure Python course on exactly how to do this stuff, so you can get comfortable with doing API calls, seeing how the models work, and then getting the stuff that or honing that skill and knowing exactly what you're doing. And then after that, I have to say thank you guys. Thank you for listening. If you were expecting code, I'm very sorry. If you weren't expecting code, you're very welcome. Yeah, my name is Pieter Gouws, and I am glad you guys know a little bit more now.
Awesome. Thank you so much, Pieter. I think a round of applause for Pieter. Is there any questions? I know, Ashlyn, I see you've popped on. Don't you want to ask 1 or 2 questions, or is everything clear on your end? Where's Ashlyn? Is he here? Yes, he is here.
Hi, hello, good evening. In this presentation, I wasn't here for the whole presentation, but I just saw the ending part. My question is, about, agents are new now, but there's another thing that's also new, which GitHub is using for their agents, which is called the MCP server. Do you have any information on what that is?
Yeah, so MCP service is basically a tool that gives more information on using a specific service. And so there's a few apps that has gone into it. A lot of CRM systems has gone into it. And it's just basically a short message of informing the LLM exactly how to use that specific service. And it's something that you can develop yourself if you really want to do it on your services. And it's something that you can link into using what a company already gave you. It's a very interesting thing, but unfortunately we're already off to the next thing, which is also developed by Claude. It's called Skills, and that is sort of like the next thing of giving an agent a specific way of doing something and teaching it how to interact with other stuff, making it more granular and not like businessy.
Okay, there's one interesting use case that I'd like to use it for, which is I got a problem with regression testing. So I was planning to put like a Playwright MCP server and play around with that to do automation testing, with the UI GUIs and all of that, and generate a regression test report. Do you think it's possible to do that approach?
Yeah, you just have to put a lot of work into it and make sure that the agent exactly understands what you want to. There's going to be a lot of back and forth. I haven't written my own MCP server yet. So yeah, good luck with that. That's what I can say.
Okay, thanks. I did play around with it. I saw GitHub introduce that recently, a few days back. And I started to play around and I saw all these MCP words. They got the MCP servers for Playwright. They got the MCP servers for a lot of things out there. But I never really get hands-on to start developing my own MCP servers and stuff. So it's going to be very interesting to see, how the MCP is changing the game now.
Yeah, MCP, yeah, it's been around for a while. But yeah, I'm definitely sure there's a lot of resources around it and exactly how to use it, yeah.
Perfect. Thank you so much, Pieter. Is there anyone else that's got a question? Raymond, do you have a question? Are you fine? Or any of our interns, Tebogo, Samira? Okay, you had a very informative, super informative session. Thank you, Pieter. Really, really appreciate it. I even caught on quite a few things as well, coming from a person that's not super technical, but I really did enjoy your presentation. Thank you so much for your time. And thank you for everyone that signed in as well this evening. We'll have a few of these webinars throughout the year, so please do check out our LinkedIn page. And also, if you're subscribed to our LinkedIn newsletter, please do. Have a fantastic evening, and thank you again.